start. All right, thank you, Algebra 2. Here we go. Today we are doing 6-4, conditional probability, including two-way tables. We did some of this the other day. So when you have the probability of an event, that's where we're going to go P of E, that stands for probability of an event. Some might view it as the size of the event divided by the size of the sample space. Other people, you may think of it as the number of favorable outcomes to the number of possible outcomes. Another fun fact, the probability of an event is always a number between 0 and 1. So what we're going to do today is we're going to do something called conditional probability. So conditional probability, that's why there's this little bar right there. This says the probability of event B occurring given that probability A has already occurred. So this bar right here is the word given, and that tells you that you have a condition that is going to have to be met. In regular words, this would be, on example 1, what's the probability of drawing a 5 given I've already drawn the ace of diamonds? So that's what this says. This big P is for probability. Of drawing a 5. That big line there represents the word given. And then the ace of diamonds means already, that's the word already. Already drew the ace of diamonds. So that's what all those symbols are telling you. All right, so I'm going to refer to the numerator up here. So when you're finding the probability, we have the probability of the favorable outcomes divided by all possible. So the favorable outcome is the probability that I draw a 5. So the favorable is that you draw a 5. Divided by all the possible outcomes that are left. So we talked about cards the other day. So the current question is, how many 5s are in a deck of cards? 4 of them. There are 4 in a deck of cards. This given right here means that I already took the ace of diamonds out. If I took the ace of diamonds out, how many possible cards are left in the deck now? How many cards are normally in a deck? 52 normally. This says, hey, I already took one of them out. Therefore, you would have 51 cards left in the deck. I am pretty sure that is a fully reduced fraction. Good final answer there. Number 2 is not a conditional probability. So if you don't see the word given, it's not conditional, it's just a regular one. A card is drawn from a deck of cards. Oh, no, it is. Determine the probability that it's a jack, given it's a face card. All right, so I have the probability that it's a jack, given it's a face card. So we basically need to know how many jacks are in a deck of cards. 4 of them. So there are 4 jacks in a deck of cards. I think we talked about this the other day. How many face cards are in a deck of cards? There are 12. So a face card is the jack, queen, king. There's 3 in each suit. There are 4 suits. Therefore, there are 12 of them. So this is saying How likely is it that I draw a jack, given that is out of all possible face cards? So we have 4 jacks in the deck of cards. We have 12 face cards. So this is how I determined what my numerator and denominator were going to be. And now I know that I need to reduce this. So 4/12 shall reduce down to 1/3. The other way that we use conditional probability is in what we would call a two-way table. So I have a two-way table, and it has to deal with the passengers that were on the Titanic. So the Titanic sank in 1912 after hitting an iceberg, and we need to answer these questions. So we have a column of people that survived. We have a column of people that did not survive, and we know there were a total of apparently 1,317 passengers. There were 324 first-class passengers. There were 284 second-class passengers. There were 709 third-class passengers, and giving us a total of, once again, 1317. You randomly select a passenger from the manifest. What's the probability that the passenger was in first class? So if it didn't have words and if it had the parentheses, what is the probability that you selected a first class passenger? So if you look up above, we basically want to have the favorable outcome, this is my favorable outcome, divided by all possible outcomes. The probability that I draw a first-class passenger. So how many first-class passengers are on the ship? 324. So you have 324 in your numerator. How many passengers are on the ship in total? Good. 1317. So when it says the probability that you select a passenger from the manifest, it didn't seem to restrict the passengers in any way, shape, or form. It was just talking about the grand total. Number 4 is different. What's the probability that you select a passenger from the manifest who didn't survive, given that they were in third class? This word given right here totally changes your denominator, and it changes all your possibilities. All right, so basically, I want to find the probability that a person didn't survive, given, this is your denominator, they were in third class. So as soon as you see the word given, that is automatically going to restrict it to either one of the rows or one of the columns. So this says I have 709 third-class passengers. So when you see the word given right there, third-class passengers, you are only allowed to play in that yellow highlight column. So, how many people in the yellow highlight column did not survive? 528. That is your answer. So, These aren't too bad, but they do take some getting used to the vocabulary and what you're allowed to do. So as soon as you see the word given, I automatically highlight, and then that restricts all of your answers to just that particular row in this instance. All right. The next one says, what is the probability that a passenger selected at random survived given they're a first-class passenger? All right, so now, given they're a first-class passenger, so on number 5, that has to do with this circle right here. So now, all I care about is this row right here, because it says, given they were a first-class passenger, that suddenly restricts it. All I care about is this row right here. So I can look and see that there are 324 first-class passengers, so that's how I know what my denominator is. What's the probability that a person selected at random survived? How many people in the first-class passenger survived? 201. That is your good final answer on that one. I have red. There we go. Number 6 says, what's the probability a passenger selected at random was a first-class passenger given they survived? All right, given they survived. So now we are talking about this survived column. So now this is how we are changing it. So it completely matters what word it uses, because sometimes it restricts it to a row, but sometimes it restricts it to a column. So given they survived tells me that's what my denominator is. So however many people survived, that's your denominator. We are going to select a first-class passenger. So how many first-class passengers survived? 201. So between 5 and 6, your numerator is the same thing, but your denominators completely change depending on how the problem changes. We're going to keep going with this. In a class of students, the following data summarizes how many students play an instrument or sport. What's the probability that a student chosen randomly from the class does not play an instrument? All right, so what's one of the differences that you see between the prior graph and this graph? What did the last one have that this one is missing? The total. So sometimes you will just be given this, and sometimes you will need to create your own totals. So how many people played an instrument? 7 played an instrument. How many do not play an instrument? 21. I should have made this even smaller than I did. And then finally, what is your grand total of people in this table? 28. All right. What's the probability that a student chosen randomly from the class does not play an instrument? So I'm looking for, So I don't see the word given or of, so I'm not restricting this one. So I'm looking for the probability not play an instrument divided by all the people. This is the probability that I am looking for. So how many people do not play an instrument? 21. 21 people do not play an instrument. Out of 21. So 21 out of 28 do not play an instrument. So if it doesn't use the word given, then it's probably talking about the entire grand total. Number 8, I thought that I would do a word one and make you create your own. I'm going to pause the video and you give that a try. All right, we have 29 students. That seems to be our grand total. 5 play basketball, 16 play baseball. Okay. So I set it up as basketball, no b-ball, and a total. And then, oops, I need to squeeze another one. We have baseball, no baseball, and I put a total in there. So this is one approach to doing it. We have 29 students, so the first thing that I knew is that I could put a 29 in there. 5 of them play basketball, so it gave me that total right there. 16 of them play baseball, so I knew that number right there. There are 10 who play neither sport. So at the cross section of no basketball and no baseball, I knew that 10 kids go there. And then, quite frankly, I just went ahead and did the math for everything else before I moved on and even tried to answer it. All right, so here, you just have to subtract. So if 29 is your total, I went 29 minus 5 means that that number is 24. To figure out this number, I went 29 minus 16, so there's a 13 there. And then here it just became like a little puzzle. If it adds up to 13, that one must be a 3. And then I looked across. If the no basketball adds up to 24, that one would have to be a 14. And here, if that adds up to 5, that would have to be a 2. So I took the words and I filled in what I could, and then I backfilled it. All right. The essential question is, what's the probability that a student chosen randomly from the class plays both basketball and baseball? All right, so I don't see the word of or given, so it's talking about the entire class. So that's what made me choose 29 as a denominator. The probability that they play both, so this 2 right here is at the intersection of basketball and baseball. So 2 kids play both sports, and so that's how I ended up with that fraction right there. Number 9 is the same thing, except now we just have more rows and more columns that we have to work with. All right, so we have people's ages, we have people's education, and we talked to a grand total of 17,207 people. If a resident who has a master's degree is chosen at random, what's the probability that they are age 50 or over? if a resident who has a master's degree is chosen at random. All right, so this one doesn't use the word given, but it does say if, and so it is restricting it to the people who have a master's degree. That's apparently the only people that they care about. What's the probability that they are age 50 or over? So 625 are 50 or over, and so this would be, the probability is 625 out of 2871. And it does say round to the nearest thousandth, so therefore you should stick that in your calculator and round it to the nearest thousandth, and I did everything except for that portion when I did my notes. .217694. Tenths, hundredths, thousandths. So that is in the thousandths position. And when I look to the right, that is a 6, so therefore that will round that up. 0.2, gosh, come on. 0.218 is what I'm going to go with. Maybe a long time ago you worked with Venn diagrams. So whether you have a two-way table or a Venn diagram, it really says the same thing. So on this one, I have people who have a credit card. So it says C are the people with the credit cards. It says L are the people with loans. And S is the grand total. So the first thing to try to understand how to read it, how many families have a credit card? So the credit card, we're talking about the entire circle of C. So this 45, those people have a credit card only. And the overlap, 61 people have both a credit card and a loan. If you look over here at the 12, those are the people that only have a loan. So the families that have a credit card would be the 45 plus 61. So there are 106 families that have a credit card. How many people are trying to pay off a car loan? So the car loan is the other circle, so that's the one that I did the little red hash marks in. So we have 61, again, that's in the overlap, plus 12 people that only have a car loan. And so therefore we have 73 families that are trying to pay off a car loan. How many families have both? 61. You are looking at the intersection there. Ooh, this is a long video. Okay, let's keep going. Almost done. Find the probability that a randomly selected family has a credit card. All right, so we just found that out. So I know that the credit card people, that adds up to 106. So I couldn't squeeze everything. So I have 106 people that have a credit card from those two. Find the probability that they have a credit card. So I need to find the credit card people divided by all people. So I have to figure up what is this S? What is my grand total right here? So basically you need to add up everything. You need to add up 45 plus 61 plus 12 plus 10. $128? Good. All right, so of the people that I talked to, so these 10 people that are outside of here, do you know what's their deal? They have neither. Neither credit card nor a loan. They don't have anything. So the probability that they have a credit card is 106 out of 128. Find the probability that a randomly selected family has both. So the both is going to be your numerator amount, and then your total number is going to be your denominator amount. So I have 61 out of 128. Find the probability that the family has neither. So you already told me that that's what these 10 people down here. So this is 10 out of 128 because I didn't use the word of or given. And the next one is just to kind of practice making a Venn diagram. And we're going to stop for now.